Hello, my wonderful grade fives. I'm so happy you're joining me on this Wednesday, May 13th, for your math. So, without any further ado, grab your math, turn on your math brain, get ready to do some fractions, and know that I would like to see a picture of your last two pages with the fractions work that you did, okay? So, if you don't need to send me the whole thing, but I would really like to see your fractions, okay? So please send them to me either on Class Notebook or as a direct message on Teams. Either is completely fine. Please send them to me when you're done, because I just want to see where you're at now. If you do it and you're like, I think I got them wrong, don't panic. That's what I need to see, right? Because I need to see where we're going next week. So please send me your work for this one, okay? Without any further ado, let's get going. All right, so let's get started with our word problem Wednesday. So it says, Yummy Ice Cream Parlor sells single scoops for $1.25 and double scoops for $1.90. How much will it cost to buy 2 single scoops and 2 double scoops? Okay, so to do that, we're going to do some addition today. So remember, when we're adding with money, it's a decimal. That's nothing different than adding regular numbers, adding whole numbers. Decimals aren't irregular. They're just like a number form of a fraction. So that's $1.25 and this $1.9. But we can express it as 0.25 and 0.190. Or sorry, 1.25 and 1.90. So to buy 2 single scoops, I'm going to do this over here. I'm going to go 125 plus 125. Now 25 and 25, imagine when you're counting your coins, 2 quarters is 50 cents. And $2 or $1 is just $2. So this is how much your single are going to cost. 2 single. Okay, and now let's move on to our 2 doubles. So 190 plus 190. Now, if I was counting this in real life, I would just do $2 plus $2 and then subtract 20 cents. So $2 plus $2 is $4. I was going with cents here. And then I'm going to subtract from $4. I'll just go back 20 cents. So it's going to be $3.80. Okay, and if we were to do the math, 9 and 9 is 18. We'd put that 10 up there, and then that would give us 3. Sometimes with money, it's easier to think of it like you would be holding the coins. Okay, so this is 2 singles or 2 doubles. Now to find our total, we have to add the cost of 2 single ice creams with the cost of 2 double ice creams. So we stack them on top of each other. $2.50 plus $3.80. Okay, and we're going to add them together. 0 and 0 is 0. 5 plus 8. So think of your facts, your addition facts. 5 plus 8 is 13. So we put a 3 here. And then I'm going to put, that would be 30 cents. And then, because it was 13, and 10. You're no longer in tenths here. You now have $1 because you had 13. Imagine you had 13 dimes. It's $1.30. Okay, and now I add all my dollars: 3, 4, 5, and then $6. So it would cost $6.30. Okay, so that is my total. So I could even write it would cost $6, you put your decimal point, and 30 cents. It would cost $6.30. How much change will you get back from a $20 bill? So now we need to do some subtraction. So to subtract, we are going to do $20, and I'm going to write it out in full decimal points. So I do 20.00. It's not just $20, it's $20.00. And then we are going to subtract $6.30. Okay, so one thing that I am going to tell you, and I think I've mentioned this before in my videos, but when I used to work as a cashier, if you start at $6.30 and you count up to 20, that's a really good way to do it in your head. So say you're somewhere and you need to figure out change for something, start at $6.30 and count up to 20. Now, what do I mean? Okay, 6.30, let's count our pennies to get to $7. 6.30, 40, 50, okay, and then 50 cents. So it's 70 cents. And then we count from $7 up to $20. So I count 7, 8, 9, 10, plus 10 more is 13. Now let's just double check using subtraction so you can see that I'm not making this up. This is actually a way you can do it. So we're going to have to borrow, we're going to have to break that 20 into a 10. And then here we're going to have $10, but we're going to borrow one of those dollars to break up into decimal points. So now I have $9. And this is 10/10 of a dollar. Oh, I'm going to break that up. And now it's 9/10 of a dollar. And then I have 10 cents here. Oh, I didn't actually need to do that. What am I doing here? 0 subtract 0 is 0. 10 subtract 3, ignore this here. 10 subtract 3 is 7. Okay, 90, or not, sorry, again, we're in dollars. $9 subtract $6 is $3, and $10 subtract nothing is still $10. So I have 1 10, 3 ones, and 7 tenths. Okay, my hundredth spot, my second decimal place, I didn't actually have to do anything for because it was a 0 on top of a 0, so it just stays a 0. But I had to regroup. But do you see how I got the same answer? And I actually find it easier to count up from the $6.30 and make it to 20. Because when you're out somewhere and you're shopping, that's the quickest way to do it. Although now everyone has calculators, but when I was a girl, that was the quickest way to do it. So the change that you could get back is going to be $13.70 is your change. Okay, and when we write dollars, we just put a dollar sign there so we know we're talking about dollars, because there's lots of different ways to describe currency. My next one is, what is the least number of bills and coins you could use to make the change? All right, well, we're going to need a $10 bill. Okay, and then I'm going to need a $2 coin, a toonie. That gives me $12. Then I need a $1 bill, or $1 coin. We used to have $2 coins when I was a child, but those have been phased out. So 10, 11, 12, 13. I've made my $13. Now I need to make my 70 cents, and there used to be a 50-cent coin. I don't think there is anymore, so I'm going to go 25 cents. 25 cents, that makes 50. And then I'm just going to put a 10, a dime, and a dime. So let's count it all together. $10, $12, $13. And then I have my pennies or my cents here. I'm going to put my decimal point. So there's my dollars. Point 25, 50, 60, 70 cents. So $13.70 in change. Okay. Now we are going to move on, and I'm going to try something different. I'm glad I got a new camera because it might be easier for you guys to see. But I got a new camera that should be able to, zoom in on these a little better. I've noticed in some of your work, and this is not your fault, and it's nothing bad. It's just a habit that you want to break now before grade 6. Because the math is just going to get more challenging with more things to juggle. So I have these grids here, and what I'm noticing is people's math, when they hand it in to me, it kind of drifts off to the side, and we're not keeping our division and our multiplication in place value. So this isn't just a 5, it's 500. This isn't just a 2, it's 20. And well, this is just a 9. But this number, the place where the number is, and that was our whole first unit of math this year, the place where the number is determines its value. You need to keep all these in line when you're doing math. Otherwise, it's not going to be very accurate, and you're going to get confused once we start working with different numbers. So just put these here as a reminder. And I'm going to start with this one here. So let's begin. Okay, so I look at 7. 7 doesn't fit into 5. It's a 0. I don't need to go do all that stuff because I don't have a lot of room here. Once it's a 0, we just assume that we take this number here. And again, if you want to go through and do all of that, that's fantastic, guys. Go for it. I totally support you practicing your algorithm that way, but you don't have to, is my point. So the next step, you just look at 52 as that whole number. So 52 divided by 7. Okay, and you think, how many groups can I fit in there? Well, the closest one I can think of is 7 times 7. So 7 times 7, the closest seventh fact would be 7 times 7 is 49. So I think, okay, 7 times 7 is 49. So I go through and I say I can get it in there 7 times 52, subtract 49. Okay, and then I do my subtraction here. So count out 49, 50, 51, 52. There's a difference of 3. Okay, 7 won't fit into 3, so I bring down this 9. Okay, I bring down the 9. And in that 9, sorry, I'm just turning off my Teams notifications because I can feel it. I can hear it going off in the background. I'm sorry if that was distracting you. That is my life. Okay, so I look here and I go, how many times does 7 go into 39? And I think about it. Okay, well, I know 5 times 7 is 35, so it's 5 times. 7 times 5 is 35. Now I subtract to find the difference. 9 subtract 5 is 4. The difference is 4 because there's no difference between the tens. Okay, now I don't have any more numbers to bring down, so you know what that means, guys. You know, and I shouldn't have written this here, but that's okay. You know that that means we have a remainder of 4. So it's 75, remainder 4. Remember, you just write R4. It can be a capital R, it can be a small r, it doesn't really matter. Okay, so that is the first one. And I'm gonna move on to the next one. So how many times does 4 go into 1? 0 times. I'm not going to do, but you can do 4 times 0 is 0, subtract, but we're now working with the 15. Just in the interest of space, I'm going to go right to the 15. Now, 4 goes into 15 4 times. 4 times 4 is, 3 times, Mrs. Oakes. 4 times 3 is 12. Okay. And I'm just going to write this correction above so you can really see. It is 3. Sometimes when I'm speaking on camera, it's hard to keep my facts in my head and focus on what I'm saying, but that's okay. I'm learning. 4 times 3 is 12. There's a difference of 3. Now, 4 doesn't go into 3, but I'm going to bring this 3 down. So how many times does 4 go into 33? And you think about your 4's facts, okay? Well, it's not 9, but 8, right? Oh, my pen is, hold on. All right, I've fixed my pen issues, I think. So 4 goes into 33 8 times. 4 times 8 is 32. Now I subtract, and I find that I have a difference of 1. I have no more numbers to bring down. So my answer, I'm going to write up here because my 3 is so messed up. 38, remainder 1. Okay. And that is that one. Okay, now I'm going to move on to number 3. So it's asking, how many times does 5 go into 297? 297 divided by 5. So I start by looking here. Okay, 5 goes into 2 0 times. So now I'm going to think, how many times does 5 go into 29? 5 times. 5 times 5 is 25. Now I subtract to find a difference of 4. 5 does not go into 4, so I bring down the 7. How many times does 5 go into 47? 9 times. 5 times 9 is 45. Now I subtract to find the difference of 2. Okay, and so my answer is, for 297 divided by 5, it's 59, remainder 2. Okay, now my next one, I'm just going to try and make this less distracting on your eyes. There we go. That's better. So my next one is, how many times does 6 go into 517? 517 divide by 6. So first we look, 6 goes into 5 0 times. Again, 6 times 0 is 0. We're going to work with this 51. 6 goes into 51. So think of your 6 times tables. 6 times what is 51? Nothing. There is no 6 times for 51. So none of my 6 facts fit exactly into 51, but I do know that 6 times 8 is 48. Okay. So I'm going to go with 8 because we will have a difference, but it's not quite 6 times 9 yet, so that's okay. So 6 times 8 is 48. Now we find the difference, 48, 49, 50, 51. There's a difference of 3. Again, you could do your grandpa's way if you want, or you could just use the count up strategy. 6 goes into 3 0 times, so I need to bring down this 7. 6 goes into 37, so think of your 6 facts. 6 times 6 is 36. There's no fact that's exactly 37, but 6 times 6 is 36. I have a difference of 1. No more numbers to bring down, so it's 86, remainder 1. Okay, and I hope that long division is starting to make some sense to you. I am going to be asking for a video of long division. I'm going to do a Flipgrid of long division next week so that you can show me how you're doing with these steps. Now, if that made you go, oh no, maybe you should watch this video and watch some of my other videos and start to practice those steps, because there's nothing scary about it, I promise. It's all good. Now let's go on to Wednesday. I'm going to zoom out a bit for Wednesday's daily math. Okay, so let's move on to our daily math. It says classify the following triangle. So I have scalene, isosceles, or equilateral. Now, equilateral means they all have the same length, and so that one cannot be it. Okay, now I'm going to move on to a scalene or an isosceles triangle. So an isosceles triangle is one with at least 2 equal sides. Now, if you look here, these 2 sides look equal, so I believe the isosceles triangle is our best bet. Now, a scalene triangle, just so you know, a scalene triangle is a triangle which all 3 sides have different lengths. So this one, these 2 are the same, so it's not scalene. So scalene, everything's different. Equilateral, everything's the same. Isosceles, 2 are the same, 1 is different. Okay. The next one is how many faces. So I look here, how many faces, and I count. 1, 2, 3 on the front, 4 for the bottom, and 1 behind. So there's 5 faces. How many lines of symmetry? I see 1. I could fold that one. If you see another one, let me know, but I don't think there's any other way to fold that W. Number 4, draw a reflex angle. So we've been talking a little bit about angles. I'm just going to go over. Remember, an acute angle is less than 50 degrees. It's just cute, and less than 90. A right angle is like a square. It's 90 degrees. An obtuse angle is bigger than 90 degrees, but not bigger than 180. 180 degrees is like a straight line. Okay. A reflex angle is an angle that is bigger than 180 degrees. So it's bigger than a straight line. Okay. And you can see here, this is the angle part. So it's almost like I have, so acute, right, obtuse, and then I have here, it's open all the way, and that's a reflex angle. So we'll draw 2 lines, and we'll show that the angle we're measuring is here. That is a reflex angle. Classify the angle. We just went through this, so I can tell you this is acute. This is an acute angle. It's so cute. All right, on to the next page. Hooray! You did it. Thank you so much for tuning in for math. Thank you for showing up. Thank you for taking the time to do your work. It really means a lot to me because at this point, this is for your own learning and you're showing up for yourself, which makes me happy, but it should also make you happy for yourself because you're showing up for yourself, and that is very awesome. All right. Have a great day, guys, and I will see you on Friday for your next math video.